A ship traveling at 21 meters per second in a straight line parallel to the shoreline passes a speedboat on the beach as shown in figure C8. At a distance of 3.5 times 10 to the 4 meters. If the speedboat can travel at 31 meters per second, find the straight line intercept path that the speedboat needs to take to meet the ship. How long does it take for the speedboat to reach the boat? What is the distance traveled by the speedboat? Okay, so again, draw a little diagram to make sure we understand the problem. So we have a shoreline. So here's our speedboat. And then we have a ship. And it's traveling with a velocity, let's call it V ship. Okay, so I'm going to make my directional vectors I hat and j hat. And we're told that the distance from the ship to the shore where the speedboat is, we'll assume that the speedboat is traveling at the speed and we know that this displacement where the ship is located, let's call it D, is actually right over here. D is given by 3.5. Is that 5? Yeah, it's 3.5 times 10 to the 4 meters, or 35 kilometers away. Okay, so our speedboat, and so the question is, find the straight line path that the speedboat needs to take to meet the ship. How long does it take the speedboat to reach? So we know that, so D is 3.5 and we're asked to find V speed. The speedboat is 31 meters per second. V ship is 21 meters per second. Okay, so somewhere the speedboat is going very fast and will meet the ship at a certain time t. So if we look at it, the position of the ship, let's go P ship, is this d vector plus v ship times t. So d vector, actually let's put in numbers. It's okay. D j hat is up and across plus v ship times t in the I direction, I hat. That's the position of the ship. So t we don't know. So this position changes as t progresses. So v ship is 21 meters per second, d is 3.5 times 10 to the 4 meters. The position of the speedboat, let's call it speed, is equal to, because it's a, let's assume this is the origin. I'm sorry, I should have said this is the origin for coordinate system. So this is our x-axis and this is your y-axis. The speedboat is traveling at v speed times time. That's position. So we don't know what angle that the path takes. So let's call this angle theta, the angle that the speedboat's traveling at. And so we can translate this into v speed. So the component this way is going to be cosine component. This is the sine component. So this is v speed cosine of theta. Theta is unknown. I hat plus v speed sine of theta j hat times time. When they hit each other, then the position of the ship and the position of the speedboat must be the same at a certain time t. So basically, we don't know what theta is, I'll circle it. And so if we equate both equations together, when they hit each other at the position of the ship and the position of the speedboat, they must be equal to each other. So we find that dj plus v ship times time I hat must be equal to, I'll put the t inside here, so it's v speed times time cosine of theta I hat plus v speed times time sine of theta j hat. So I'll circle things we don't know. So we know the I component must match the I component, so we get two simultaneous equations. V ship times time must be equal to v speed times time cosine of theta. So here's the I terms. Here's the j terms. I put a happy smile face there. So here's this circular arc. First equation, I components are equal. And the second equation says that d is equal to so dj is equal to v speed times time sine of theta. Okay, so we don't know what t is. We don't know what theta is. So look at the equations. And if you look carefully at the equations, you'll see that t drops away in this equations to get an angle for theta. So we could say that v speed so v ship, the speed of the ship, is equal to v speed times cosine of theta. Theta is unknown, so we can find what v speed is. First equation. So actually, since you might not want to do these calculations, so the question is, how long does it take the speedboat to reach? So we have to find t. So we can solve for t. So let's put numbers in here so we can solve for theta. Actually, the equations look a little messy, but the numbers we can plug in numbers directly to find cosine theta. Theta is equal to, move this to this here, so it's going to be arc cosine of v ship over v speed. Which is equal to, so we'll just plug in directly numbers because it's much faster when you plug in numbers when you have it pressed on an exam. So where is the calculator? Oh, there it is. So v ship is equal to inverse or arc cosine of v ship. V ship is 21 over 31. The actual answer should be only two significant digits. but since we're back substituting into another equation, right, you should take it a couple more significant digits than 2. So 21 divided by 31, shift cosine equals 47.35, 47.35 degrees. So now we can plug into this equation and find t. So t is equal to d divisible by v speed times sine of theta. And theta is given by 47.35 degrees. So d is equal to 3.5 times 10 to the 4. V speed is 31. Sine theta is sine of, so the actual angle you should be using theta is 47 degrees, but since I'm back substituting into another equation, I'll go to a higher precision than 2 significant digits. 47.35 degrees. So our time, plugging it in, 3.5 exponent to the 4 divided by parentheses 31 multiplied by 47.35 sine close parentheses equals. So I get the final answer is what we require. So that has to be 1.5 times 10 to 123, 3 seconds. So there's 3,600 seconds, so roughly about 25 minutes, 20 minutes around there to get there. So that's t. And the next question is, what's the distance traveled by the speedboat? Since I still have a number, if I'm going to do some calculation with numbers, right, you should exceed the 2 significant answers. So it's really 1.535 times 10 to the 3 seconds. And the distance traveled is basically the speed times time. Speed times time. So distance traveled by the speedboat is going to be 31 meters per second times 1.535 times 10 to the 3 seconds. Ideally, you would actually want to solve equations, but when you're pressed on time in an exam, you should actually try to use numbers. Only after you've solved the equations and you know what equation to substitute into. So multiply by 31 gives me, final answer is going to be 4.8 times 10 to the 1, 2, 3, 4, 10 to the 4 meters. 1, 2, 3, 4. Yeah, 4.8 times 10 to the 4, 4.75. If you're going to use this number to a higher, if you're going to use the back substitute distance into another equation, then you shouldn't use just 2 significant digits. You should increase it to maybe 4 significant digits, like 4.75859. Anyway.